In this video, let's take a closer look at net ionic equations. A net ionic equation, if you recall, is an equation that shows only the substances that are actually involved in the reaction. Ions that are not directly involved in the reaction are called spectator ions. Spectator ions appear both on the reactant side and the product side of an equation and can be ignored since they do not take part in the reaction. They can be identified as being aqueous before the reaction and aqueous after the reaction. Once the spectator ions are removed from the equation, the ions and substances that are left over form the net ionic equation. Here's a sample problem that shows how to write a net ionic equation. Aqueous silver nitrate and aqueous calcium chloride react to form solid silver chloride and aqueous calcium nitrate. First, balance the equation. There are 2 nitrates on the product side and only 1 on the reactant side. Balance that by putting a 2 in front of the silver nitrate on the reactant side. Notice that the chlorides are not balanced either. There are 2 on the reactant side and only 1 on the product side. Balance the chlorides by putting a 2 in front of silver chloride, which also balances the silver. Now this is a balanced equation, and you're ready to eliminate the spectator ions. Look for the ions that appear as aqueous on both sides of the equation. Notice that nitrate is aqueous on the reactant side, and it's also aqueous on the product side. So nitrate is a spectator ion. It did not take part in the reaction. Another ion that is aqueous on both sides of the equation is calcium. It's aqueous before and after the reaction. You can eliminate calcium as well, since it is another spectator ion. What you're left with is the net ionic equation. There are 2 silver ions, and they are aqueous on the reactant side. There are 2 aqueous chloride ions on the reactant side, so write those in. And those combine to form 2 units of silver chloride, and that is the precipitate in the reaction. Here's a second example of an equation to be converted to a net ionic equation. Again, you first balance the equation and treat the polyatomic ions as units when you balance them, rather than the individual elements that make them up. You see that there are 2 nitrates on the reactant side and 1 nitrate on the product side. Balance the nitrate by putting a 2 in front of the potassium nitrate on the product side. That not only balances the nitrate, but it also balances the potassium, because you'll notice there are 2 potassiums on the reactant side. That 2 in front of potassium nitrate gives you 2 potassiums on the product side. Now the equation is balanced, so look for the spectator ions and eliminate those from the equation, and you're left with the net ionic equation. Nitrate, as it always is a spectator ion. Notice that potassium is also a spectator because it is aqueous both before and after the reaction. When you write the substances that are left over after you remove the spectator ions, you find that you have aqueous barium before the reaction plus the sulfate polyatomic, which is also aqueous before the reaction. Those 2 combine to form the precipitate, barium sulfate. So now we have our balanced net ionic equation. 1 aqueous barium ion plus 1 aqueous sulfate ion combining to form 1 unit of barium sulfate, which is the precipitate in this reaction. Here's one for you to try. Aqueous potassium iodide is added to aqueous lead-2 nitrate to produce lead-2 iodide and aqueous potassium nitrate. Go ahead and press pause, give it a try, and then press play to check your answer. Let's see if you got it right. To balance the equation, put a 2 in front of potassium iodide and a 2 in front of potassium nitrate. The spectator ions were potassium and nitrate, and so you eliminate those from both sides of the equation. And then, when you bring down the substances that are left, you see the net ionic equation, which shows that the aqueous lead-2 ion combined with 2 aqueous iodide ions to form the precipitate, lead-2 iodide. If you got that one, that's great work. For more chemistry matters, go to our homepage, where the entire series is available to you.